Alrighty, and we are live. So it's the new hour, the new session. Welcome to the next session of the Qgis Open Day. To everyone who is joining us for this fantastic session, we have Jannik in the room with us, and he is going to be taking us through preparing models for rainfall runoff simulations and drainage network modeling with SWIM. I decided that's how it's said. And it usually starts off with spatial data. All of that modeling and rain runoff simulation starts with spatial data. So this session is going to be on how you can prepare your different layers within QGIS and just generally use the plugin to import and export model files. I'm super excited to see how this all works. So over to you, Jannik.
Thank you, Amy. To start, I can maybe start with a short introduction on SWIM itself. It's another open source software provided by the US Environmental Protection Agency, EPA. And it looks like that. Here's already a really simple model, which I just drew with one catchment or subcatchment in here. Then there are several nodes and some links between these nodes, which can be a drainage system or a river or whatever. And what this software does is it has a rainfall runoff simulation, which runs in this catchment here. And then there will be a hydraulic model for the calculations of water flows and water depths within this drainage system in here. This is a, as I said, very simple model in here, which has only one catchment, 4 nodes and 3 links. If I wanted to add another one, I could just draw it in here like that. And then I add the attributes or properties manually, and I would do that for every other object that I want to add to this model. Now, if models are getting larger, this would be a lot of work. And to show you what I mean by large, I have another model opened in here where I already did some calculations. And this one has about 14,000 subcatchments and 5,000 nodes. And of course, I didn't do that manually for every object. And the first idea that I had was, where is all this data saved for the model? And when you're looking at the folder where it's saved, then you have a so-called input file. And this input file looks like that. It's a text file where you have certain sections. Then you can have comments starting with these 2 semicolons. And then in the other lines, you have every object defined, starting with an identifier, which is always the first characters that you have in here. Then there's a sort of separator, which is normally blank lines. And then you have values, which are here in a table-like format. And of course, you could think of that like something that's similar to values in an attribute table. So I thought, why not write something that could translate my data from QGIS, where I already have this data about rivers and drainage systems and subcatchments and things like that, and have it translated into this input file, so I could load it everything into my model. And I began writing Python scripts, which did this for me at the beginning, just for certain sections, starting with points, which were then translated into coordinates. And these coordinates were inserted as X and Y values into this text file. And after some time, I really needed it very often, so I decided to write a plugin about it. And this plugin now has two main functions or tools. The first one is you can select certain layers in your QGIS project, and if you want to, certain tables like Excel files or open document files, maybe comma separated values as well, and translate it into this input file, which is just the text file, and then you can use it as your model data. And later on, I needed the other way around too. So I wrote another tool which could translate this input file and create certain layers of it, which you can then use in QGIS. The plugin itself is loaded into QGIS like every other plugin with the plugin manager here. I have installed it here, and I do not have the normal version. I have some version where I added the latest tools that I'm just creating now. And to give you an overview about the functions, I thought I just would test them here. And the problem is, if you want to have all the information in your model, you have to have it somehow in your attribute table before. And for the tools to get the right information, you have to have the information in certain columns in your attribute table. And because everyone who uses this tool has to know how the columns names should be, I created the first tool which generates an default data set. For example, I can open it, and I want to have a test data set for the latest version of Swim, which I select here, and then I select a folder to save it somewhere, maybe default data set, and then I run it, and it should add all the layers, which is this other data set. I can group it. Default data set. Okay, so now I can show this. The default data set. This is the default data set, and it has different layers for different objects. For example, here we have the layer for the subcatchment, or subcatchments. There are two subcatchments. Then storages, which can be any type of storage. For example, it can be a lake or it can be a storage tank. Then we have a rain gauge, where we have our rainfall data defined. And we have a pump here, and so on. And to get this information into Swim, we need the second tool later on. But first, I want to show you the attribute table of one of these layers. For example, if I open the layer, the attribute table for the subcatchments, I have here a name for every subcatchment. Then here's the name of the rain gauge, which has to be the same one as the one that I want to use here. Then I have to link it to some node, which is defined here in the column outlet, and so on. Every column is described in a documentation file, which will also be added to the same folder where we just saved our default data set. I can open it here, and there's the documentation file. I can open it here, and here are the descriptions of my geodata and what I need in the columns. But if you're using it for the first time, you can just use this default data set. I don't know why it disappeared. Huh. Okay. Somehow it disappeared. Maybe now. There it is. Now my background map disappeared. Okay. Anyway, now if I want to export this into an input file, then I open the second tool where I can select different layers. For example, here with the rain gauges, the rain gauges layer, then for some junctions and so on, subcatchments, storages, outfalls, dividers, pumps, wares, orifices, and outlets. And I could also select different tables here if I needed them for my model in Swim, which I will do now, because they are here, the options, and curves. I can do that a bit quicker if I just copy the path and then change it. Time series, inflows, quality. Let's have here. Yeah, maybe streets and let's also. And then I select where I want to save it. Save it to a file, maybe test default. And when I click on run, then it saves it here, and I can open it. No. So I have, oh, there's something wrong. Maybe I forgot something. An undefined node. Oops. So I have to see again. Oh, I took the wrong rain gauges. I have to take correct ones here. Swim. And this seems correct. So another try. Oops, that didn't work as well. Okay, maybe I selected another wrong layer. Here it is. Junctions. There. is another wrong layer. Outlets. Out false has to be out false. Dividers pumps. That seems correct. Okay. Last try. And here it is. So I have all the features that I just had in QGIS now here in my model. And what I didn't show you just seconds before, of course, there is more information in these tables here, which I will not explain in detail now, but maybe I can do it later when there are questions. This is just the default data set, which has all the features in it, which are possible in Swim. Normally, you would not use every feature type. The second example that I had here is more simple. It has just one outfall node here and some nodes which are manholes in general. Then some drainage system, some subcatchments, and of course another rain gauge. And that was my test file this morning. Now, if I want to import an existing input file, I can use the third tool. I just select one input file. I wanted to import this one here. And I can select whether I want to import it as a shapefile or geopackage or other file type. I will choose geopackage now. I can add a prefix, for example, import, and I have to know the coordinate reference system. Otherwise, it will be loaded somewhere in my project where I don't know where it is. And of course, I have to select a folder where it will be saved. I will save it here. And when I click on run, then I have it here, and I will move it on top of my project. Zoom to layers, and it doesn't show up. Why not? I don't know why, but I have problems with my coordinate reference system now. Can I zoom to the other layers? Yes, they are here. Okay, this is something that I have to figure out later. And normally they should be here. But the other map doesn't load as well. I don't know why. Okay, maybe I can move on to the last tool. If we already have our layers here, which are used for a model, and we want to create a submodel of it, just a part, maybe everything that's above a certain node, and we select one node, for example, this one here, then we can use the last tool. And of course, we have to tell the correct layers here again. Junctions, conduits, subcatchments. We don't have storages, but we have one outfall node and one rain gauge. And we say it here. Click on run. And now it creates a submodel or a subset of the model that we had before. And it just contains everything above this node that we just selected. Okay, this one works. But I still don't know why these aren't in my project. And I don't understand why my background app isn't here as well. I don't know. Okay, these are the main functions of it. Yeah. If anyone tries this and something doesn't work, like it just did here, please write an email or write me on GitHub. And if you're using it and you find it useful, maybe you can also write an email and just talk about it with me. Yeah, that's it.
Awesome. That is fantastic. Yeah, CRS, hey? Tim, I see you unmuted.
Well, just going to say it's fantastic. And I was just wondering if you've collaborated with other Qgis water-related projects and like maybe want to contextualize where your work fits in with the other tools that you've looked at, and for the watchers out there so they can understand.
Yeah. Well, this plugin I developed by myself. I'm working at the university in Rostock, and I'm working in a research project on spatial data in the context of regional planning. Yeah, and therefore I build models for large drainage systems.
But I sort of meant in relation to other water modeling and management tools in Qgis. Have you looked at the other tools out there, and have you like thought about how it can interoperate? For example, there's a GIS water tool.
Yes, I have looked at that. I found it a bit too large and too complicated for beginners because I wanted something where you have simple tools and don't need a database for it. Mm-hmm. So you can work with single layers, and you can make copies of layers, and then you do some calculations on one layer and just change one layer in your tool to create a new model. Yeah.
That's my questions. Yeah.
Going from that, so this, how does this perform with larger data sets?
Well, it does need some time to get all the geometries into X and Y information for the input file. But I've prepared larger models of up to 50,000 subcatchments, which will take about 3 minutes on my computer. So I think it works quite well.
Fascinating. And is it mainly urban sort of water drainage and networks, etc.?
Yes, it is. I think Swim is originally made for drainage systems in cities, but you can also use it for open channels, and there's the option to have certain, well, I had it here.
Because I'm just thinking for like, open channels or even irrigation channels in an agricultural context.
Mm-hmm. You can define cross sections with different shapes, and there is the option to have so-called irregular shapes. They are here, and you can then have the shape of the cross sections with another X and Y table, and have open channels in the fields as well.
Okay, cool. And then how can, obviously you've built this plugin and people, you're showing it and people want to use it. How can people get in touch with you, have a look at it? Are you on GitHub, etc.?
Yes, the plugin is on GitHub and I'm on GitHub, and people can just comment there or write me an email. I think my email address should be here at Plugin Manager as well. If I click here, it should open, yes. And you can just write an email. Here or here on the GitHub page.
Awesome. I do encourage all of our viewers to please ask any questions in the live chat for me to read out, and anyone in the room, if you do have any questions, to please send those. I kind of wanted to just ask you towards the end of the session about your journey writing this thing. Because you said, you wanted specifically something that worked with not database data, things that you could duplicate and work on several times. But I'm quite interested in the model process and what you went through to build your plugin. So can you just kind of give me a summary of that? Sorry, okay. A little bit out of random.
So I think there are two main tasks. The one is, how do I get the information from the attribute table into the model? And the other one is, how do I access the geometries of the features? And both tasks were initially performed just by separate Python scripts. One was extracting the geometries and then adding it to tables where you have the feature ID as an identifier, and then the geometry as well-known text, I think it's called. And this was afterwards written into this input file. And the other functions were there to translate and separate tables from each other, or join tables to prepare them for the input file. And yeah, that's the main thing. Maybe the third step was to set up the style files to get this appearance like it is in Swim, and also the feature forms when I open it here. Unfortunately, I didn't see the other presentation this morning where the really cool feature forms were shown, but I will work on this right now to get more easy accessible feature forms. I already tried it, for example, for the subcatchments can edit the infiltration method here, and then it changes the fields where you can write your data in. But that's the last step right now.
I think that'd be really cool. And then my very last question is who do you envisage using this plugin? Do you think that, city data planners or, who is the best people to be using this and testing this and just helping them make their lives easier?
Well, we are showing it here to our students to use it for the preparation of their models when they are starting in QGIS, and then later on work in Swim. And yes, I hope this will be used by spatial planners. There's a Swim user group where we have email groups, and it was asked a few times if there would be a tool to somehow import spatial data into Swim, because there's no function for this. And maybe this plugin fills the gap. I don't know if it is used somewhere else. I didn't get much feedback so far.
All right, brilliant stuff. I think that's all of my questions, and there aren't any in the live chat or the chat in the room. So I think I'll start rounding down the presentation for this session. So it just leaves me to thank you so much, Jannik, for showing us this really, really cool plugin. And it's very cool functionality to be able to use within this context. And I think there are a lot of applications for this. Obviously, in my mind, the one that just popped up was perhaps agriculture, as well as, in the urban environment and in, drainage planning, etc. So thank you so much for showing us. I do encourage you all, everybody who's watching, to go and try this out, and do send Jannik an email with your feedback, etc. Thank you, everyone, for joining.
Thanks, Jannik.
Okay.
Brilliant.